In this video, we will see another graph algorithm, the Dijkstra algorithm. Edgar Wybe Dijkstra was a Dutch mathematician who lived between 1930 and 2002. The problem, what we want to solve, is to find the lower cost between two vertices. In our example, we want to know the lower cost between vertices A and F. The Dijkstra algorithm is working with two sets, S and Q. The S contains the vertices where the lower cost is known, and Q contains the other ones. How the algorithm works? Set the cost for every vertices to infinite, or the maximum number which can be stored in a property in the selected programming language. The cost of the starting vertex is 0. Select the vertex with the lower cost. Get the neighbor vertices and update their costs. If the new cost is lower than the previous one, then we update it, otherwise we leave the stored one. After this, we continue from the second point. Do the algorithm until every vertices has moved into the set S. Let's see an example. As we can see, every cost is infinite but the starting vertex, that is 0. We move the vertex A from the set Q into the set S because we know its cost is 0. Then we update the neighbor's cost. The cost of B will be 2 and C will be 4. So we continue with the vertex B. We can move it into the set S. In the next step, we will update the vertices which are the neighbors of the vertex B. From here we can reach the vertex D with 1 cost and E with 3. So the cost of D will be 2 plus 1 equals 3, and the cost of E from A will be 2 plus 3 equals 5. The next vertex is D. From here we can reach vertex E. 3 plus 5 is more than the previous cost 5, so we leave it there. The next vertex is C. From here we can reach F, and we can update the cost of F as 6. Finally, we need to examine the cost of F from the vertex E, but because it is 5 plus 6 equals 11, that is more than the stored cost, so we leave the previous value. Now we know the lower cost between the vertices A and F is 6. Let's see the source code. The function of the Dijkstra algorithm is waiting for a graph as an input parameter. It creates two lists from the vertices S and Q. S is empty at the beginning, and Q contains all of the vertices. Start a loop until Q will be empty. Select the lower cost vertex and move it into the list S. After it, we iterate through the neighbors of the selected vertex and update their costs. The time complexity of the algorithm is E log V.